Hello everyone and welcome to another Oxford MAT Livestream. My name is James and excitingly today I'm joined by one of our students, Flora, who's going to say hello now.
Hi, I'm Flora and I'm a third year maths student at Mansfield College.
Thank you, Flora. We're sharing the square at the top here, and Flora's going to help out with some of the maths things today. Hi to people in the chat. Hi to Harriet and George and Lucinda and some anonymous people. If you want to join chat, there's a link at the bottom of the screen there. And we're going to start with some maths. I'm going to remind everyone what the point of differentiation is and what that means from first principles. So if you've got a function and you take 2 points on the curve, A and B, and something you could do is draw the line, the chord, between A and B. It's a nice, sensible thing to do. That gives you some sense of how the function is behaving. Is it increasing or decreasing? I guess in some over some interval, over some region, whether overall across there is it going up or down. If you hold A still, but you move B towards A, so maybe I move B over here somewhere, line, and you keep moving B closer and closer towards A, then this chord that you get, if I extend it out to be a line, this chord gets closer and closer to the tangent. And the tangent is the line that just touches the curve at that point, that has the same gradient as the tangent, so same gradient as the derivative of the function, and has the same value. Now, if you're in A-level maths and further maths classes and stuff like that, then you've learnt loads of stuff about how to differentiate particular functions and how to work out the derivative. And that's great. It means you can work out the gradient of the tangent and then do maths to work out these tangent lines to curves. It's a really nice thing to be able to do. But it's worth remembering, where does this actually come from? What's the actual relationship between derivatives and these tangents or chords like this? Cool, right, okay. I really like seeing people's usernames in chat. Someone's gone for x plus i1, which is x plus iy, which is absolutely great. Okay, let's do a poll. We usually do a poll at the start. The poll is a rating out of 5 stars. I think I've set that up right. How do you feel about integration and differentiation? Is this sort of stuff, this sort of stuff on the MAT syllabus, doing just, if you've seen a lot, then just doing derivatives of x to the a and e to the kx and doing integrals, finding areas, thinking about increasing and decreasing functions. That differentiation from first principles thing I just mentioned. The summing things and integration. If you're happy with that, and you could vote something like 4 or 5 stars. Oh, Flora, look, it's like the first thing we've had where 5 stars might win.
Wow, that's great.
Everything else has been a bit of a tie between 4-ish kind of times. Oh, it's very tight at the top there. Okay, people are voting on how they feel about integration and differentiation. I always keep an eye on the people voting 1 star, 2 star, or maybe even 3 star. If you want to do some revision, if you want to see some maths, maybe you've never seen it before, but you want to learn about integration and differentiation, I've written some brief revision notes in the revision section of here. I'm not going to go through them now on the stream, but if you want them, they're part of the worksheet, which is on the Mat Live website. Link down there somewhere to pick that up, including things about derivatives of sums not working in the same way as derivatives of not working in the same way as squares of sums, and all of that stuff I just said about chords is written in a nice paragraph there. So if you didn't catch it live, then there it goes. 5 stars is winning. It's amazing.
Oh, brilliant.
That's really nice. Somebody would like a poll for how everyone's day is going. I haven't set one up. I might interrupt in a minute. We'll see how everyone's day is going after we've done some integration.
Exactly.
Anything you want to highlight? No, I think I'm going to hand over to Flora to do some warm-up problems. Let's move that over there. Over to Flora, I think. Let's get taken through.
Okay, great. Hi everyone. So I'm going to go through a choice few of these warm-up questions, and I'm going to start with this one. I'll get the pen out, that would be helpful. Oh, why isn't the pen working?
Ooh.
Had a strange mishap. My pen isn't working well. Oh well. So, oh god.
Do you want me to write?
No, it's okay. So, find the tangent to this curve. So we start with y equals e to the x plus x squared at x equals 2. So this is the function. To find the tangent, first we're going to need to differentiate it.
Yeah, okay.
Pen's not working. Oh no, it's working again. It's working again. That was strange. So, plus... So I've differentiated according to the rules, which you can see in the revision. Basically, e to the x doesn't change when we differentiate it. X squared is just the normal rules of multiply by the power and take 1 away from the power. So, why have I differentiated? Because we need to find the gradient of this line, which is the tangent. And to find the gradient of this line, we need to know what the gradient is of this curve at this particular point, x equals 2. So when x equals 2, what is dy dx? Well, dy dx is e to the 2 plus 2 times 2, which is, of course, e squared plus 4. So now we know that we have a straight line, and we know that the gradient is e squared plus 4, and I'm leaving it in that form because if you think about what e actually is, it's a long decimal number, and it's not going to be any nicer if I try and write down what e squared is, so it's nicer in this form. So we're going to have a straight line, and it's going to have gradient e squared plus 4. So we're going to use y equals mx plus c, and then we're going to solve for c, because we want the point x equals 2, and we know what the curve is, so we have the equation x equals 2, then y equals e to the 2 plus 2 squared, which is, funnily enough, e squared plus 4. And this is where you might get confused because you've got the same number in different places. But I'm not going to get confused. I'm going to say, okay, so when x is 2, y is e squared plus 4. So e squared plus 4 equals e squared plus 4 times 2 plus c. So then if I kind of rearrange that for c, I'm going to take away 2 times e squared plus 4 from both sides, and I end up with c equals minus e squared plus 4. So I'm running out of space, classic. Y equals... yeah. E squared plus 4 times x minus e squared minus 4. Yeah. And so that is the equation of the tangent. Hopefully.
And I like the way there's part of this where you have like the equation of a line. You have like the equation of a line. You've got a choice about how you write the equation of a line.
Yeah. I could factorize it. I thought about this in my head. I didn't want to confuse everyone straight away. But if you do this, you've got minus one of them. So it's like times x and then times minus 1. So it kind of looks neater if you write it like that.
Yeah, you get the what's it called, x-intercept out of that, which...
Oh, yeah.
Yeah, I don't know. Oh, it factorizes nicely, so let's maybe just write it like that.
Yeah, nice.
Okay, cool.
So, I'll move on. I'm going to jump straight down. I might come back to one of the other ones if we have lots of time. I'm going to jump straight down for now to this interesting one with pi and x to the 2021. Now, you may be thinking, why have we got such a weird number? I mean, obviously, it's the year. But I'm just going to work through it, and then we'll realise that it's not actually as scary as it might look. So, you got pi to minus pi, x to the 2021, or 2021, as I should say, so as not to confuse myself. So standard rules for integrating a power of x. We're going to add 1 to the power and then divide by the power. So it's going to be 1 over 2022, x to the 2022. And then the limits are still pi and minus pi. I'm writing too big. And then that's going to be equal to... I'll just take out the 1 over 2022 out of the front, and then we're going to have x, we're going to substitute in pi for x. So pi to the 2022, and then minus, and this is where you have to be really careful with your minus signs, minus pi to the 2022. So that looks a bit of a mess, so I can simplify it a bit by saying, well, okay, sorry, that's messy. Pi to the 2022. Basically, minus pi to some power is the same as minus 1 to the power times pi to the power. So I'm going to take out the minus 1. So when you have minus pi to the 2022, this is just minus 1 to the 2022, and then pi to the 2022. And this, what do we know about this? Well, it's an even power, and even powers of minus 1 are always 1. So we can get rid of that, it's just 1. In which case, you have minus just pi to the 2022. And then, surprise, surprise, it's 0. Because they're the same thing. Just moving that out of the way. Brilliant. And now, that may seem kind of surprising, but then when you think about what this graph looks like, and what an integral represents in terms of the area under a graph, it's going to make a lot more sense. So I'm going to draw a very small, very beautiful diagram for you here, which goes like this. Whoa. So this, my friends, is what the graph of y equals x to the 2021 looks like. It's basically like the graph of y equals x cubed, but squished and squished and squished until it makes an almost squarey shape. But anyway, all graphs of odd powers look something like this. Like odd powers of x, and so you know that the area here, the area here is going to be the same as the area here. So obviously when the area is below the x-axis, it will cancel out because it's negative. It's like area can't be negative, but what you'll get out from the integral is a negative sign times the area under the graph. So it cancels out to 0. Magic. Brilliant.
People in chat are calling that a result that's like an odd function thing.
Yeah.
If you've got a function where f of x, if f of minus x is equal to minus f of x, and if you're integrating between minus a number and positive that number, and I think people in chat have seen that you always get 0 as the answer to that, for kind of the same reason as you've got.
Yeah, that's great.
Here. I'm probably going to have to rewrite this question every year that we do the MAT Livestream, because I've been stupid and I've put 2021 in. And,
yeah. I mean, it would work next year, but it's always more fun when they do stuff that relates to the actual year, isn't it? Like on UKMT, they always do that. So
it's a bit UKMT, isn't it?
It's a bit UKMT.
People in the UK maybe do maths challenges that tends to write questions that use the year as an arbitrary big number. We don't do that so often on MAT. There's a couple of times we've done it on MAT, but
yeah, it gets to the point where you're going into a maths exam. Like I had a number theory exam, and going into it, we were like, okay, know the prime factorization of the year that it is. What is the prime factorization of 2021? You've got to be ready because they're going to use it somehow. And it didn't actually come up.
I'm not doing that on MAT.
No, it's fine. No, I'm not saying that for Matt. That's not for Matt. That was just me. Yeah, and what I find interesting is, of course, odd functions are called that. It's named after the odd powers because, like, x to the 3, x to the 2021, and so on, they are all odd. And so that's why they're called, like, an odd function. Odd powers of x all fit that, but obviously there are other functions that fit that as well. Hint, hint, trigonometry. Okay. So now I'm going to move on. And I'm going to tackle this first integral here, which is this one. And now you may be thinking, oh no, it's a fraction. What do I need to do? Like, is it partial fractions? I haven't done integrals like this yet because I'm fresh out of year 12. And actually, it's not as scary as it looks. When you have a fraction where there's two things on the top and one thing on the bottom, you're allowed to split it up. Now, it's very important to remember that if it was the other way around and you had like x plus 3 on the bottom, you can't split it up easily. Like, that's when you have to do something more complicated. Because I think that was something that used to confuse me at school. Like, just check in your brain. Two things are on top, not on the bottom. So here we have x plus 3 over x cubed dx, which is simply x over x cubed plus 3 over x cubed. Sorry, that's a mess. dx. I'm going to go to the other side because there's no space. So if we basically simplify that, x over x cubed, I've got 1 power of x on top, 3 on the bottom, so it's x to the minus 2. And then plus 3 times x to the minus 3 dx. And so now it's just a simple case of integrating with the usual rule for powers of x. So you add 1 to the power and divide by the power. Got to check my algebra here. And then plus. It's like, I couldn't decide how to write that, but it's a mess. And then we don't have limits. Silly me. It's yeah, that's it. I mean, it's messy, and I would write it nicely, like minus 1 over x minus 1 over 2x squared. There you go. That looks much nicer.
There are 3 in there as well. There might be a 3 missing.
Oh yeah, I knew I'd missed something. Yeah, there's a 3 on top of there. Sorry about that.
Molly was first person in chat to ask you to add a plus C.
This is why you always check you're working, or even better, get your friend to check you're working, because you just trust yourself. You know, when you read through your own working, you're just like, yeah, that's right. Yeah, that makes sense.
Payham wins the silver medal for being the second person in chat who would like a plus C. I'll add a plus C in, don't worry.
Oh, sorry, I didn't hear what you said.
No, it's cool.
No, I always add plus C. Always add plus C. Sorry, I just went off on one about the whole... Oh.
It's sort of not important because everyone knows there's supposed to be a plus C.
Oh, it is important. It's always important. Me as a sixth former, I was a strong advocate for plus C.
Pro plus C. Right.
Yeah.
Should we do another one of these? I tried to write these to catch people out, to make them look harder than they are. Yeah,
let's do another one. Which one? The final one? That would confuse me when I first looked at it.
X squared plus 1 to the power of 3?
Yeah, so this one.
Oh.
I just got my highlighter out. It's getting serious. So yeah, x squared plus 1 to the power of 3. You're like, oh no, it's a power, it's a thing, it's like year 13 content, except no it isn't, because what you can still do, which you probably learnt years ago, is expand brackets. Well, I hope you can anyway. X squared plus 1 to the power of 3. Oh, everyone's going to be sad now because I'm going to want to do it this way instead of the other way. I don't trust myself to do it the other way off the top of my head. Mind you, have they learnt that yet? I can't remember.
I think, well, we're doing a 2-stepper, and that's all right. We're going to go for a 2-stepper.
So yeah, 2 steps. Nice. God, it's been a while.
2x squared, I think.
2x squared plus 1 equals...
Maybe as many as...
4?
Yeah.
Oh, I'm writing it out.
Okay.
And everyone who doesn't like that can be patient with me because my brain's slow.
Conversation about chat about whether we know the binomial theorem or not.
Yeah, so I didn't know whether everyone knew it, so I didn't want to start going on about it. That's the official narrative. The real narrative is that I was going to mess it up if I did it live. But the fun thing is that even if you don't expand using the binomial expansion, you can look at it when you're finished and be like, oh yeah, 1, 3, 3, 1. I trust myself that is the correct thing.
Looks good, doesn't it? Looks correct.
It looks nice, like a nice pattern. Like, you know, you've got your whole this thing going on. So now you can be happy.
Yeah. If you're watching
anyway. Sorry?
Quick PSA. If you're watching at home, we've learnt recently that it's super hard doing the maths on the live stream. So if you're watching at home and you feel like you can do this faster than us, you probably can. Right?
Oh, absolutely. I'd do this faster if I wasn't, you know, live on air.
Cool. We're going to integrate all these functions, Flora.
Well, I can integrate, believe me.
Yeah, there's quite a few of them.
Yeah, so then you're going to have x to the 7 over 7 plus... I'm not going to forget this to 3 this time, everyone.
3.
Oh. Plus 3. Oh, but this time over 3. That cancels. Bye-bye.
Nice.
Plus c.
Cool.
You can't see it because I've gone into the hint on the next page, but it is a plus c. Okay.
Cool.
Right, should we talk about the last one?
Yeah, I want to mention briefly. So, people in chat asking if they can do this with the chain rule or with integration by substitution or something.
So chain rule.
I suppose those are the same thing.
I don't know. Oh yeah, chain rule kind of is substitution, but without actually substituting, isn't it? But the whole reverse chain rule thing, I don't think would actually work with this one, because when you do reverse chain rule, you have something that looks like f dash of x, and then you have f of x like to some power, or you have like, if you want to get really technical, you have g of f of x, where g is some other function. So here we have the whole function to the power of something, but we don't have like the derivative of that in front of it. You would need there to be like some multiple of x in front. Like if you had an x in front, then you could do it. Am I right?
Yeah, no, you're right. If there was an x out the front, then this is easy with the kind of chain rule substitution stuff. I know that some people watching haven't seen that. Don't worry, we're talking about an advanced way to do the question. That's why we didn't do it. An advanced way to do the question, which then runs into a problem. I think if you make the substitution x squared, please don't forget that you'll need to have a factor of 1 over x in there. So your new integral to do will be u plus 1 cubed over the square root of u, which, I mean, it's actually the same difficulty of integral to do, because you probably still need to multiply that out. I guess maybe you could do x squared plus 1 as your u, and then you're doing u cubed divided by root 1 minus u squared. No, I don't want to do it. Okay, I don't want to do it with the chain rule.
The amount of maths you do in your head right now is really impressive.
I've thought it through. I don't want to do it with the chain rule.
In my head.
An anonymous person who's watching with a little bit of lag has just said 1331. So
I rate that from them.
When they see this, they'll be happy that their comment was read out on the stream. Okay, should we talk about this last one, which is kind of a setup for one of my MAT questions that's coming up.
Yes.
This thing? Maybe over here on the left bit.
Yes, sorry about that. So we're going to think about the area that this integral represents and explain why that equals that. So what area does this integral represent? So I'm going to draw a graph relatively big so hopefully everyone can see. Say we have some function that goes like wibbly woo. This is y equals f of x, okay? So what area does this integral represent? Well, it represents, this is minus 1. Oh, they're not even. Oh well, trust me. That's minus 1 and that's 1. And this integral we're going to have to split it up. If you read the revision material, then you'll see that it's easier to consider separately the region where it is below the x-axis and the region where it is above the x-axis, like this. So we've got these two separate areas, and this integral represents like the area above minus the area below, because the area below gets a minus sign in front of it when you do the integral. So it represents this area minus the value of this area. And so now we need to think about, I need a different colour again. Now we need to think about what does f of minus x look like. So if you've studied graph transformations, then hopefully you remember that if you put a minus sign in front of all the x's in the function, then that flips it in the y-axis, because you are flipping the x values, so it reflects in the y-axis. Now this is something that confuses a lot of people, but you think of it as the minus values in front of the x. So if you have like x over here, hi, I'm x, it goes over here to become minus x, if that makes sense to everyone. So we're gonna
Graphs and Transformations episode.
Exactly. So we're gonna flip this, and now I've totally played myself here and drawn it complicated. But just pretend that this is a perfect mirror image, okay? So this is f of minus x. So then you're thinking, okay, what does this integral represent? It's the same thing, it just has minus x. So it's going to be, surely it's going to be this area minus this area. And now hopefully from graphs and transformations and just from the idea of reflection in a basic sense, you can see that we have two areas that are the same here and here, and two areas that are the same here and here. So once you think about the diagram, it becomes clear that the areas are going to be the same, because it's just the top area minus the bottom area, and when it gets reflected, you have the same areas, just in a different place.
Brilliant. Love it. So
yeah, I really like that, because it looks like complicated, but when you think about it kind of graphically, it makes complete sense.
Yeah, it sort of doesn't even matter where the blobs are. So we've got an example drawn, but it doesn't even matter where the bits of positive and negative area are. If it's all positive area, then it just flips around. And because one and minus one flip.
It could have been like that or anything, and then you would still have like, oh, okay, mirror image is like that, so then you'd have this, or you'd have this, and it's basically the same thing.
Yeah, it doesn't have to go through the origin.
No, not at all. But even if it went through the origin more times, you know, it's always going to kind of cancel out when you flip in the y-axis.
Cool. Just to answer a question in chat. Right, cool. Okay. Thank you, Flora. Do you want to do... Oh, we kind of skipped a lot of the warm-up problems. Do we
I was gonna. Might head back and do a normal question, because we haven't talked about normals.
Oh, ooh.
Oh, do you not want to?
After I made the sheet, everyone, I realised that one of the questions in the warm-up is the same as one of the things in the revision material. Do you want to do the normal at x for x squared, or do you want to do a different thing?
Yeah, I'll do a different thing, that's fine.
Also, someone's asked our two running jokes, which are, can we use complex numbers today? And also, what A-levels did do? Those have both appeared in chat now.
Okay, to answer the A-levels question, I did maths, further maths, RS, which is religious studies, and Spanish, and I did an EPQ. As for the other question, I mean, there is such thing as complex integration, but you will not encounter that until you get to university, sadly for you. Okay. Shall I...
Yeah, do you want to have a go at... Well, should we differentiation functions at the top? Just to sort of balance it out with a bit of differentiation?
Yeah,
and then we'll look at
some
some
lots of
questions.
integration.
Yeah, cool.
Okay, so let's look at this second one, because it looks like a mess. I'm going to go Shall I delete some of this stuff over here so that I've got space?
Can
Should I
we
just go
left
above?
or
Yeah, left is good. Yeah, if you're ready for me to. Yeah. Okay, so let's say we've got y equals. So I'm going to write it differently. The square root of x is the same as x to the power of a half. And some people might be sad that I'm using fractions versus decimals, which is a whole debate, but just go with it. 3, and here we have the cube root of x. This is just to confuse you. You know what the cube root of x is? It is x to the third. X to the 1/3. Okay, so using our usual rules, we multiply by the power and then we take 1 away from the power. So a half times 2 is 1. Taking 1 away from a half gives you minus a half. And then a third times 3 is also 1. Taking 1 away from a third gives you minus 2/3. And you have to be careful with fractions like that. It's easy to get confused. So the answer is this, or if you want to write it the way they wrote it, minus a half means it's the negative power, so it's like reciprocal fraction. That's what I meant to say. And then it's a half, so it's the square root, and then you have. Oh, this is a bit of a messy way to write it, but you have like that.
Cool. Nice.
That's
No, that's lovely. That's a nice way to write it with radicals.
Okay, fair enough. I guess it kind of relates it to that, so you can compare them.
There's a request for there's a winning comment at the moment.
Go on, what is it?
People are arguing about fractions and decimals, and I don't know why.
Oh, of course they are. I feel like I started that debate, and I'm sorry.
I missed what you said. I missed what you said about fractions.
I said some people are going to get annoyed about whether I'm writing it as fractions, or they want me to write it as decimals, or they don't. But I'm just going to write it as fractions for now. So.
Okay. There's a request for the normals question, but the normals question is in the warm-up, so in the revision. So I think we'll call the warm-up there. Thank you, Flora.
That's okay.
Quick break for 2 things people have requested. 1, I would actually like to know how people's day is going.
Aww.
Also, people want to ask Flora about, someone's asked, I think this is Spanish, ¿Aún puedes hablar español, Flora?
Sí, puedo hablar español.
Brilliant. Right, okay.
That's so sweet. I'm going to reply to him in Spanish.
Lovely, right, okay. Flora's going to hang out in chat as well, but I'm going to take over for the Matt question part. Flora, I'm not going to mute you, so if you want to interrupt... Okay,
so I can still talk.
If you want to interrupt, then that'll happen too. Also, people are now commenting in Spanish, so the moderation has got really tricky for me. I can't moderate that. Please be polite and respectful in the chat, in the comments, even if you're in Spanish.
If they use Spanish, which is too advanced, then I just won't approve it if I don't know what it means.
Muy avanzado. Right, okay. Cool, and we're going to go out some Matt questions in a mo. We like to do polls on the Matt questions. Somebody's voted 1 star on how their day's going. And the rest of the votes look...
I hope we make it better.
The rest of the votes look exactly like whenever I ask how do you like sequences and series or something. Okay, maybe there's a strong correlation between how people's days are going and how they feel about maths topics. Right, cool. Should talk about some maths. And people are asking you about St Anne's College. You're not at St Anne's College, right?
I'm not at St Anne's. I'm sorry, everyone. I don't know any St Anne's stereotypes. You'd have to ask St Anne's students.
I think there are too many colleges to have college stereotypes. There's like 29 different colleges.
Yeah, only a couple of the famous colleges have stereotypes, really. And my college is the one that no one's heard of.
I also can't believe that any of the kind of like college myth stuff is true, because all the students change so frequently. So I can't believe it. Cool. It's awkward having one of us on screen at a time, isn't it?
It's fine.
The rest of them can't see who I'm talking to anymore. Right, cool. Wow. Okay, good. Right, sorry, chat has gone into Spanish mode as well. Just a little bit. Does that happen in Toy Story?
Just a little bit of French as well. It's all good. I'm handling it.
I'm glad everyone's day is going at a 4.0 rate. That's good enough for me. We're going to do some math questions based on integration. I've got a bunch of these and about 25 minutes to do them. So we're going to try and speed run speed run the first couple, I think. If you've got ahead, maybe you tried the worksheet before the live stream, or maybe you've been trying the questions during the warm-up time. I'm going to turn on a poll so that you can vote straight away if you've been joining in with what's been going on with Matt question. If you haven't seen the Matt question yet, don't worry. I'm going to read it out. We're going to do it. Don't worry that people are already voting. Right, okay. We've got a cubic. This is the first question. We've got a cubic. We'd like to know whether it has a turning point, which is a local minimum. So a turning point, comma, that is a local minimum, comma, when x equals 1 precisely for which values of k. And the word precisely here is doing a bit of work. The word precisely here means we can't just describe, we can't just say, oh, probably some of the k for all k. We want to know exactly when it happens. So we can't just give an example of just for k equals 1, that works. I checked. Need to look at some other stuff as well. Good. Okay. People are voting already, which is nice. I'm going to try and do the maths really quickly. I want to find the turning points. I want to find the local minimum. I think my strategy is just to try and work out where they are. So I'm going to differentiate this curve. I want to put a 2 in here for differentiating. When you do that, so that's dy by dx. That's the derivative. Come on, computer, we can do it. When you do that, these are k's. That's a 2. You find out that at x equals 1, this just is 0. So if I plug in x equals 1, then I get 3k. I get minus 2k's here, and I get plus another k. Oh, do I mean all these minus signs? I want a plus sign here, don't I? Ha. So I think all the numbers cancel out. So this just is 0 for all k. So it's looking a bit like E at the moment. It's just 0. Whatever value of k I've got, when I plug in x equals 1, yeah, that appears to be magic. It's a turning point. I need to check that it's a local minimum though. So this question is also checking that I can check whether things are local minimums. So I need to work out the second derivative, which is, am I getting this right? I think I'm getting this right. 6kx minus 2k plus 1, which when x is 0, at x equals 1, this is 4k, still got a minus sign there, minus 2. For a minimum, I want this to be bigger than 0, for this to be a local minimum. That happens when k is bigger than 1/2, so I get C. Oh, and chat's also got C, with some votes for E, which I understand. If you voted for E, I totally understand that. Because for all values of k, something is going on. This is 0 derivative. But sometimes it's a maximum, sometimes it's a minimum. Okay, good stuff. Thanks for voting in my poll. People are changing their votes. Okay, right, good. You see, now it's up to like 91% on C. Right, okay, good. I sort of think this question is putting together ideas that you have quite early on in A-level maths about differentiating things, and I like the way it's got these parameters k in to mess around with, to see what happens for different values of k. A slightly interesting extension might be to try plotting this, to try drawing it as a curve sketching practice for different values of k, or even stick it in Desmos and with a slider for k, and see as you change k, I think you know what's going to happen from what we've worked out. I think you already know, but it might be fun to stick it in desmos.com and move a k slider to see that happen. Okay, right, good. This is one of the ones where the hint is not very helpful. Like, the hint here, if you didn't know what local minimum was, then you maybe didn't know what a second derivative was either, so maybe the hint's not too helpful. Okay. People in chat, Emmanuel says, maybe we planned this for dy by dx to be 0 for all k. Maybe we did. I'm really sorry if that caught you out and made you answer E. Right, okay. Miro is brilliant. Hearts for eyes. Okay. Cool. Right, let's have a look at the next one. Similar idea. How much do I love this one? I'm going to skip this one. This one's quite similar to the previous one. We've got a cubic. It's got a value of k in. If you'd like to try a question that's pretty similar to the previous one, but do it yourself, then on the worksheet, I've put 2017 question 1A, solutions coming tomorrow as well. Have I missed anything from chat? I think we're good. Okay.
Just me trying to explain Spanish.
Okay, right, good. We're learning Spanish with Flora in chat. Thank you, Flora. Which is classic. Right, okay. I want to talk about 2014 question 1J. Which has this hideous looking equation. 6 plus f of x is 2 times f of minus x plus 3x squared times, oh my word, the integral from -1 to 1 of f of t to t. We're asked for not to find what f of x is, and actually when we do this question we won't work out what f of x is. We're just asked to find the integral from -1 to 1 of f of x dx. Which we can do. I wonder if people want to tell me. Oh yeah, there's a suggestion in chat already. Give it a name. Okay, which I quite like. So maybe an important thing to spot when you're trying to do this question. Sorry, I'm trying to catch up with chat. An important thing to do when you're looking at this question is to realise that this object here, this is the same. That the letter we use when we do the integration doesn't matter. This is just a number. In fact, it's the number that we're looking for. So if I give this a name, like A or something, this is also equal to A. People in chat know what to do.
Yeah.
People in chat have got some suggestions about integrating this. Good stuff. Yeah, people have got different suggestions about how I might do that. I suppose the reason you might think of that is possibly from the hint, where I suspiciously tell you about the integral of f of minus x, but possibly also because, well, I don't really want f. I don't care what f actually is. I want to work out the integral of f. So hey, if I just integrate the left-hand side, that's going to give me something involving the integral of f, which is what I want. Okay, this is slightly tricky to do because the right-hand side is now the integral of 2 times f of minus x. I can be clever on this next term because this number a, well, it's just a number, so I can bring it outside of the integral. Okay. So all I've done is write down integral signs on both sides, mostly because I wanted to turn the thing on the left-hand side into the sort of object that I was getting. Somebody's agreed with me that the hint was helpful. This is a question where the hint was helpful. Good stuff. And it's related to the warm-up integral as well, where
Exactly.
Flora, yes, thanks Flora. Flora convinced us that this integral here, if you're integrating f of minus x, that's equal to, it's the same thing as integrating f of x from -1 to 1. It's just asking you to flip the area, which keeps the area the same. Okay, so in fact, this is 2a plus 3a times that integral turns out to be 2/3, I think. Oh, I shouldn't have done that at speed. I think that's all right. I think we're good. People in chat will tell me if I'm wrong. That's the beauty of chat.
Exactly. Someone's asking what graphics tablet you use.
I'm using the cheapest graphics tablet that I could find on the internet. It's okay.
What a great answer.
Is that 2/3? I'm getting worried now. They'll tell me if it's wrong. Surely they'll tell me if it's wrong. I think I'm going to get to a equals 4 at this rate. Maybe I'll turn on a poll and see what's going on, and they can use that to disagree with me. I feel like I got 6 the last time I did this.
We've got a good question here. Why would f of t be the same as f of x?
Yeah, well, okay, so f of t and f of x are different things.
Okay.
One is the function with t's in, and one of them is the function with x in. And if x and t are different numbers, then those are different things. But the integral, when you integrate that with respect to that letter, then all this really means is take all the values of f between -1 and 1. The actual thing that it means, that number, that area, doesn't really have anything to do with t. It's not a function of t. It just says take the values of f and kind of just add them all up. Sort of what integration means. So you can put whatever letter you like in there. as long as you put the letter inside here, and also as the variable you're integrating with respect to, you can choose your favourite letter. So that's why I'm being very careful. F of x and f of t, those are different things, but the integrals are the same number. They're both measuring that area. Okay, maybe it is 2/3. Okay, cool. So it looks like I'm going to get down to 3a equals 12. Is chat going to back me up here? Like 12 people have voted. Oh, 12 people have voted, and they've got down to, I think, the same answer as me. I'm going to go with that. We're going to bake that into the live stream. 2 people in chat and a poll.
Great.
I think A is
4. Someone said it's right, so.
Ah, cool. I should probably have looked up the answers before I went live. Cool. Yeah, so good question here from Ares aka Ross. Are you allowed to integrate both sides of an equation? Because you're not allowed to differentiate both sides. And I think I know what you've been told. You've been told that if you're given an equation, you can't just differentiate it. It was only true for like the solution value of x that we're looking for. We've been told something very special. We've been told that this is true for all real numbers x. So this is more than just an equation for a particular value of x. This is more like an identity or a kind of relation that's true for any numbers x. Because it's true for any numbers x, I can play tricks with it to say I'll take the values for different values of x, and I'll think about the function, and I'll think about the chords, and I'll differentiate both sides. If you actually open up the bonnet and look at the mechanics of what's going on, I'm thinking of both sides as functions that are equal, and I'm differentiating those functions, and as well as setting them equal to each other. Yeah, this is really powerful, being told something for all real numbers x. Okay, how is the left-hand side 12 plus a? That's a good question. So I got the 12 by integrating 6 from -1 to 1. I didn't actually do that like a polynomial. I just know that that's a rectangle with height 6 and width 2. So I got 12 for that. And then the second term is the integral from -1 to 1 of f of x dx, which is exactly what a means. It's the thing I'm looking for. So I got that. Is this called implicit integration, like implicit differentiation? I don't know.
I don't think so.
I've never heard it called that.
I've never heard it called that, exactly.
It's a little bit implicit, isn't it? Because this is an integral differential equation, but I feel bad for saying that phrase. 3a times 2 over 3 is not 0. This thing is 2a. I had 2a from here, but then I sneakily also subtracted this a, which is why it went away over here. So I got 3a. Maybe my algebra is wrong. No, I think I'm good. Cool, right, okay.
Yeah, someone's agreeing with you.
We can take a log. Why do I want to take a log? Change the product form.
I'm not sure
I don't
if they
understand
mean
that one.
with this particular problem or just in general.
Possibly. Okay, cool. It was a good question about why can we differentiate this equation, because if you're just given an equation like x squared equals 6, you can't go and differentiate that and write down 2x equals 0 and so x equals 0. You can't play that game with derivatives. Oh, it's a general fact about taking logarithms. Oh, they're talking about... Yeah, I know what they're talking about. I get it now. Cool. Good. Right. How do I feel about this question? I kind of want to do another one. Not this particular problem. Yeah, so I think there's a question in there from chat. Why can f of x and f of t both be a? And I'm being really, really careful. I'm going to go back and look at it one more time, because that's got a thumbs up. One more time. F of x and f of t are the different things. They've got different input variables. But when you integrate, the dependence on that variable goes away. So f of t depends on t, but the integral of f of t dt doesn't depend on t. It's just the area, which I've called a for area. Now it doesn't matter if I put in, as I'm feeding in numbers for this integral between -1 and 1, which is what integration means, add up the values. If you really want to dig into what it means, it's adding up the values over some little ranges. It doesn't matter what I'm naming the variables as I put them in. This is sometimes called a dummy variable. It just doesn't matter what letter you use.
That's what I was going to say.
Dummy variable, there you go. Okay, Yeah, we used democracy on this one. We had a vote. And the vote decided I was right, so, you know. Ah, good. Right.
We live in a democracy.
Good old democracy. Do I love this question? I need to decide whether I love this question and want to do it on the live stream. I put it on the worksheet, so maybe I should have a go at it. Yeah, let's have a go at it. Okay, we're going to try 2016 1H quickly, and then I want to look at the long question. I think we'll look at the long question and see what's going on with the long question. Maybe chat about the long question a bit.
Yeah.
Yeah. Cool. Okay. So 2016 question 1H, we're given two functions, and we're asked whether the area of the region bounded by the x-axis. So we're actually calculating some areas now, and the curve f of x. Matt advice, and I suppose just question advice, already at this point here, I'm thinking about just working that out. I've been asked about this. I've got this long phrase, area of the region bounded by the x-axis of the curve y equals f of x. That's some super huge phrase. I know how to work that out. It's just the integral of some parabola. So I'm going to go and integrate that polynomial, I think. I'm asked about whether it's bigger than some other long phrase, the curve g of x. So this is going to be, because of the word bigger, this is going to be some inequality or something. But already, as soon as I've got to this point, I think I want to work it out. Cool.
Yeah. Sounds good.
I've turned on a poll for voting on this one, which people are doing. I forgot to hide results, but so too late now.
Yeah, someone said you accidentally created a poll, and I was thinking, I thought you meant to do that, but maybe you meant to hide the result.
It looks right. So from my point of view, I turned the polls on at just the right time. From the point of view of everybody watching, the poll appears before I've talked about it because of the lag on the video. There's lag in the video, but not in the Slido.
Of course.
It appears on screen at the right time, but if you're playing along at home, then you get to see the poll before it's even appeared on the live stream. It's like being in the future. Join the Slido. Okay, I want to work out this area. I'm installing. So this is a minus x squared, and I want to integrate that. I suppose I want this area, so I need to find these intersection points, but I know they're going to be plus or minus square root of a, right? So it's just this. Okay, that's an integral to go and do. That's my first one. And then my second one, there's a trick here because this one, the function is negative in the region I care about. That's f. This one's going to be g. Negative, going through minus a over here, and then I guess these are like the fourth root of a and minus the fourth root of a. Let's be really careful. The area here is minus the integral. So I want minus the integral x4 minus a dx from minus fourth root of a, it's a bit messy, fourth root of a. Okay. And I want this minus sign in here because the integral is going to come back negative, but I want the positive number that is the area. Yeah, somebody in chat has put, you need to be careful with the plus and minus. Cool.
Always.
Yeah. Somebody else asks, how does it feel to live in the future? And no, you don't understand. I live in the present. You live in the future. By accessing the Slido, you're ahead of anyway. You're ahead of me all the time. Not just when I'm trying to integrate functions. Okay, how much do I want to do these? Not a lot. I think I might have a go at a couple of them. Let's see if I can make a mess of one or the other. I can see that both of these are going to be things that depend on A. My mission is going to be to write down that I want the first one to be bigger than the second one and rearrange. Yeah, Matt also says I could just take the modulus if I wanted to. I could take the modulus, putting the modulus bars around it. I know that it's negative, so somehow putting a minus sign in is more informative because, you know, I know it's negative, so I know the modulus of this thing is equal to minus that thing. Okay. Oh, shortcut. It's an even function. Thank you, Pian. Pian says it's an even function, so I could just do the integral from 0 up and then double it. Do I like my chances of doing that? Yeah, I think I might think about it like that. Okay, so this is going to be... What is this going to be? 2a to the 3 over 2 minus, this is going to be 2/3 a to the 3 over 2, which is going to be equal to 6/3 minus 4/3 a to the 3 over 2. Meanwhile, this one over here is going to be minus 2/5 a to the 5 over 4 plus, what is that, 2a to the 5 over 4. So it's a good thing I remember to put that minus sign in, because if I didn't, this thing was going to pretty obviously be a negative number, if I had those the other way around. That's 10/5 minus 2/5, which is 8/5, a to the 5 over 4. I think I've got the numbers right. 5 over 4 here, 3 over 2 here. Okay, so I want 4/3 once, 4/3 a to the 3 over 2 to be bigger than 8/5 a to the 5 over 4. Are we getting there? I can rearrange that. I can cancel some 4s, put up a 5. I think I want a to the 3 over 2 to be bigger than, what is that? It's 6 over 5. I'm getting there. You know what? I'm getting there. This is a to the 1.5. This is a to the 1.25. So I want a to the quarter to be bigger than 6 over 5. So I want a to be bigger than, a little bit careful. Is a positive number? A is positive, so I don't need to be super careful. 6 over 5 to the 4, I think. I think I get E. Cool. Yep, good. Okay. And chat, I haven't looked. Chat agrees with me. That's nice. Thank you, chat. Cool. Good. Okay. And 6 over 5 got some votes in there as well, which I understand, because the 6 and the 5 come out of here. And then if your powers are a little bit different, then maybe you don't get this 4. And maybe out of those two, you would pick the other one. Okay. I think I understand that. Cool. And also a bit of 1. I think I understand 1 if you write down, if you forgot to divide by the new power, then I think 1 comes out as the right answer. I think. Somebody wants to know, why have I drawn that like a quadratic? And it's partly because it looks a bit like a quadratic.
Yeah.
Throw it at Desmos and find out. It's also partly because I don't care. The shape of the function, just not super important for this question. I need to know where the roots are, where these zeros are. I need to know that the function is negative. But other than that, I don't really care what shape it is. Sorting out the powers of A at the end, says Josh. Okay, yeah, thanks. I like it when people say, we're practicing. This is about learning and practicing. I like it when people say what they got wrong or what was tricky about the question. Okay, cool. Good. I quite like this one. Let's have a quick look at the long question before we wrap up at 6. Maybe time for some just chatting afterwards. I saw some admissions questions fly past, which I haven't answered, which I might answer. Here's a long math question about integration. It brings in that notation again. We've seen this before on the MAT Livestream. F subscript k of x, which they're using to mean lots of different functions. So here there's a function f1 of x, which means x to the 1 over 1. But also there's a function f2 of x, which means x to the 1 over 2. And a function f3 of x, which means x to the 1 over 3. So there's this kind of subscript that means wherever this is the input x. So if you have an input to this function, you put it here where there's an x. But also there's this other number k that you need to specify for the function. Almost like a second input, or like how those logarithms go. Okay. I also like it when people say they like the questions, or don't like the questions. That's also allowed. Question was nice. Good. Yeah, it's got a good inequalities and stuff question. Or maybe they mean this question. But they're in the future, so they're already on this question. Right, cool.
Of course.
That's how it works. Or is it the opposite? Minus signs are hard. There was some advice in there as well about how I could have brought the minus sign inside the integral, or only integrated from 0. I saw, put some 2's down. People have got some shortcuts, which I like to see. Cool. How do I know? Barry would like to know how I did the integrals so fast. I've integrated a lot of polynomials.
That used to amaze me when I was at school, and you see your teacher just integrate something really quickly off the top of their head, and it's just experience, practice. The more you integrate, the more you can do it quickly. Very quickly.
This one, the first one, is it's flat. Don't even think about polynomials. It's a constant, so write down constant times the difference between the limits. Difference between the limits here is just double the top one. This one, I've integrated x squared a lot of times. Gonna get a thing cubed. It's an even function, so you put in the top limit and double. So I know that I'm going to put a 2 here. I'm putting the 2 here for doubling the limits, 3 from integrating x squared. Remember to put a cubed, but then also a square root because it's square root of a. Do the same thing over here. It's not actually tricky. Right, cool. Okay, long question. Okay, so we've got this fk of x. It's x to the 1 over k for different values of k. And this question is going to explore getting us to sketch what those look like for 1, 2, and 3, which is fine. And then there's some regions. They ask us for the regions, but that's not too bad because these functions are just powers of x. So I believe in us. We can integrate these to find those areas. There's even this general question with the value of k in here to say what's the area between those two. I'm not really sure if people learn this as a fact or just notice it for themselves, but if you've got two functions, f and g, and you want to work out the area in between, then you could think of that as being the integral of g minus the integral of f in this picture, or you could think of that as the integral of g minus f dx. Dx is everywhere. Sorry, I was being lazy there. You can think of it as the difference of the integrals or the integral of the difference. Find that bit. Okay, so here where we're finding the area between the graphs, either because you've seen something like that before or just thinking, I could do one and then subtract the other. Okay, good. Okay, and they even want us to check that we got the right answer. Okay. Next part of the question kind of doesn't have that much integration, does it? Oh no, we do some more integration to find the areas up to the line y equals c. So there's something to make sure that these areas are equal, just not too bad. Write down some integrals, integrate some polynomials, or not even polynomials, integrate some powers of x. Set the areas equal to each other, and there's some hideous equation for c. I'd like to think about the last part of the question very quickly, where it says, we've got this polynomial. We've got a polynomial session coming up on the MAT Livestream, I think. We've got a cubic, and it just says, hence find c. It's a bit of a tricky thing to be asked to do. I wonder whether anyone's got a strategy for doing things like that. Someone has just put in chat, done everything but can't solve the cubic. Same area, same cubic by finding the area between the curve and the y-axis between 0 and c. Okay. If you know how to find the areas between a curve and the y-axis, then I think that works. I think that's not on the MAT syllabus to find sort of sideways areas, but sure, yeah, that works too. George has done the same thing. George has reflected and then integrated x squared instead of square root x. George, I want to swap all your x's and 2's. Cool. People are finding c by, I think, guessing numbers. And I've got
people are talking about trial and error and the factor theorem.
Yeah, okay. I don't think I know a better way of working that out other than, just go for it. Just try small values of c. I can't remember if I learnt it at A level, but I learnt some advice for guessing numbers to put into cubics like that.
Yeah.
Do you know what I'm going to say, Flora?
I'm not sure what you're going to say.
So I saw some advice that if you've got a number out the front here, in front of the highest power, then you should think about how you're going to cancel that out by putting a number in. Or
yeah.
I think there's a fact that's not on A level about putting in, if you put fractions into a polynomial, then there's only certain fractions you need to check. I'm not going to put that into this live stream because I can't quite remember precisely how it works.
Yeah, there are some clever tricks, I think, but when I was at school, I think we just got told, like, try 1 and -1, then try 2 and -2. It'll probably be one of those.
Yeah. So somebody would like somebody would like me to show how you would solve, how I'd guess the solution.
Yeah.
Okay, so like an idiot, I would try c equals 0. That doesn't work. Then I tried c equals 1, and that doesn't work. I thought about trying c equals -1, but then I thought, I remembered just in time about the geometry thing we've been doing, or the areas, and then I went back and read this. I thought, oh dear, I should not have been trying 0 and 1. I should try a number somewhere in between. So then in between, I tried c equals 1/2, which does do something nice with this 4. It makes this first term 1/2, and then this thing minus 3/2, and at that point I'm safe. Because I've cancelled my halves, I get +1, that works, I'm happy. That's pretty nice. Okay. I think that's the first fraction I tried in between 0 and 1. Guessing, in general, there isn't a good strategy for guessing. There is a strategy for solving cubics. There's just a formula for solving cubics. I don't expect you to know it. But
a couple of people mentioned it.
Guessing is guessing, right? What's the name of that theorem? I can't even remember.
Is it Cardano's cubic formula? Because someone said that in chat.
That's the name of the thing that solves cubics.
Ah, okay.
I'm trying to remember
theorem.
the thing about putting fractions into polynomials.
Someone said they think it's called the rational root theorem.
That does sound good. That's a combination of words that I should be saying. Okay, we're gonna go and look it up afterwards.
It's a rational number. It's a root. It's a theorem.
If you want some further reading to get some more ideas about guessing things, apparently there's something called a rational root theorem. Matt did try 1/2, but then didn't get 0. So I guess persevere, try some other fractions, and then come back. At some point, your strategy has to include coming back and checking numbers that you've previously put in, so that you can get things through. Cool. Someone said, even though I can hear James, I understand nothing, which is, I think, a good point to wrap up the maths bit of today's MAT live stream. I'm going to answer admissions question for a bit. Flora, you don't have to hang around for this bit.
Okay.
Do you want to
I'll stick around for a bit.
You'll stick around for a bit. Cool. Right. Good. Okay. George has pointed out in chat that it's definitely a fraction between 0 and 1. Thinking about 4 and 6. Do you know what? I'm gonna while we're getting admissions questions in, or if I've missed anything, or other chat about integration and differentiation, see if I missed anything, and maybe try and learn the rational root theorem.
You have a truly baffling large brain.
I've thought about doing. I think a really fun live stream would be something like. I'm not brave enough to do this, but a really fun live stream would be a topic that I don't know anything about, or the person presenting it doesn't know anything about the topic, and they go on the internet and try to learn about it.
That would be hilarious.
I'm not brave enough to try and do that, to try and go, I know nothing about this. Please don't laugh at me as I go and try and learn about it. Try and look stuff up and learn it. Because I've just searched for rational root theorem to check that it's the thing I want. And now there's something to say about reading maths, right? Right, P is a factor of the constant term and Q is an integer factor of the leading coefficient. So I said roughly the right thing. That if you're going to try P over Q, you want Q to be a factor of this number, and you want P to be a factor of that number? Okay, good. And it's something to do with whether things are a multiple of P or not. I vaguely remember the proof, I think. Yeah, cool. I've just scrolled down on the Wikipedia page and it looks like something I've seen before. Cool, right. Insight into what it's like being somebody who learns mathematics. Right, okay, good. Somebody would like to know if Flora is an international student.
I am not. I live in northwest England. Not going to be more specific than that, just in case.
Yeah. Please don't dox.
I'm not going to tell from my address.
Somebody else a day in the life vlog from me, which is not what you want. I think you want like a day in the life vlog from someone like Flora, who's got like an interesting life.
Oh well, at the moment it's just been a lot of emails.
Yeah, I'm doing a lot of emails and admissions. Like my day in the life, it would get very meta, right? Because my day in the life would involve doing the live stream if it's a person.
Oh yeah, that would be quite meta.
Can we do like a Netflix behind the scenes, right? Like I'd be.
Yeah.
Okay. Okay, so questions about personal statements. Let's put that one. There should be a live stream where James talks about what he doesn't know about. It'll be a great inspiration.
You should talk about a subject that's not maths and say how much you don't know.
There's plenty of maths I don't know as well.
Well, yeah.
Some of the Oxford Online Maths Club episodes, I knew less than others about.
Yeah, that's true.
Yeah. I'm going to take the A * AB question. Ali knows the rational root theorem, so that would have worked too. Like the Learning Maths live stream also has, I guess, people in chat teaching me things. Not doing further maths is a question there. Oh, someone from comments. I saw a comment on a YouTube video from you, I think, as well. Hello. If you're watching the YouTube replies and you want to ask a question, the comments are open. Other people are asking questions too.
Apparently we should make a YouTube channel.
We're on a YouTube channel.
This kind of is a YouTube channel. Oxford Maths Plus is a YouTube channel.
Welcome to our YouTube channel. It's called Oxford Maths Plus. At the start, we told people not to subscribe because we didn't know what we were doing and we didn't know how regularly we were going to do stuff. And then they did. I think it might only be sensible to try 1/2 and 1/4. I think the rational root theorem might be a good way to prove that this thing, if we'd missed on 1/2, maybe we could have proved that it had no rational roots. That feels like something you do in a maths degree. Prove this polynomial has no rational roots.
Yeah, maybe.
I'm never sure if I should cut to you or no. If I change the 6 to a 5, then I think it has no rational roots, which is not that unlikely. Right, cool. People are requesting other live streams, which is nice. Right, okay, let's do the
English lit live stream.
Oh dear. Right, okay. I'm going to start flagging questions that I'm going to talk about.
Yeah.
Molly's got a question, which Flora's already said sounds fine, about not mentioning extracurricular activities like dance, which Oxford does not judge applicants on things not related to mathematics for the maths applicants. For computer science, Oxford doesn't judge people. In general, Oxford doesn't judge applicants on things not related to their potential to do well on the academic course they've applied for. So it doesn't matter if you don't have dance or DFE. If it's going to be in a teacher reference anyway, okay, cool, yeah.
I'm just saying, like, all the unis will see both your personal statement and your teacher reference. So at the end of the day, like, they're going to get that information, so it's fine.
Somebody says they're not doing further maths. It's someone. He said they're not doing further maths. What should I do? I always recommend that people pick up as much further maths as they can. If you're at a school or college that teaches further maths, find out whether they'll let you do AS level further maths. As a way to see more maths, get a little bit more prepared for university maths, find out if you like doing lots of maths, and also I think doing more maths helps you develop problem solving skills. It's not a disaster. You can still do some bits of further maths. We make a very small number of offers occasionally to people who don't have further maths, usually because their school or college didn't offer further maths. But we know that some people discover a love of mathematics during year 12. Okay. Yeah, okay, and then the follow-up question, I suppose, is if two people pass the MAT and interview with the same grade and have the exact same potential. I love these conversations. It's very mathsy, isn't it?
Hypotheticals.
Holding everything else constant, can I differentiate with respect to whether or not you have further maths, please? And I suppose if one of them has further maths, this is still the same thing, right? That if one of them doesn't have further maths because their school or college doesn't teach further maths, then that's not really a selection criteria. It's not something that's anything to do with them. It's something to do with their school or college. It's always hard because here I've been told that they have exact same potential, which is, I just don't know what that means. Usually, having done the interviews, we've actually met you to talk to you about maths. If you've done the maths, we've got your actual maths script as well. So we can look back at what you did, and we're quite good at making decisions between candidates. Maybe I take both. People hate it when I answer that for this style of question, but hey, maybe we take both candidates.
That's a great
nice,
answer. I love that answer.
Maybe we take both.
If they had
Sneakily.
exactly the same potential, then you would try and take both, wouldn't you? If they had the same aptitude.
They sound good. We're slightly flexible about how many offers we make. Because if we get like 1 or 2 extra students, it's not a disaster.
One college with lots of accommodation will be able to take them.
This one's important. The one at the top that says, James, if you send me your personal statement, I can't read your personal statement. I'm sorry. Partly because of conflict of interest, and partly because there are hundreds of you, and I can't read all of your personal statements. Sorry. There's loads of good stuff coming in. My laptop has died, so I'm going to switch over to here. Flora, would you mind being in charge of
Yeah, of course not.
highlighting things?
Because there's some. If I do that, does it stay at the top?
That's perfect, thank you.
Great. So, how important is choosing a college?
Cheers.
The answer is academically not important at all. If you applying for maths at Oxford, say, you'll have the same academic experience regardless of which college you go to, because the teaching is organised by the department. So your tutorials will be in college, but they'll be like the same content, the same courses, the same problem sheets. So it doesn't matter. In terms of choosing a college for like all the other parts of university life, if you want to, live near to the centre of Oxford, or if you want to be in a really big, vibrant college, then you express a preference, but you've got to remember that of the people who do apply to a certain college, a quarter of them, roughly, will end up at a different college anyway. So at the end of the day, like, college choice is not a big deal. So choosing a subject, very important. Choosing a college, not so important.
Thanks, Flora.
That's okay.
I can also help answer things if they turn up on.
Yeah,
I just can't flag them onto the screen.
Yeah, no, I understand.
Somebody else. Oh, the top one is, are
So
you satisfied
can
with
you-
Okay.
With the mat you've made? Are you
Am I
satisfied with the mat you've
that
made?
I've made? Yes. I think it's a good math paper. I think you're going to like it.
Someone else asked, can you still get marks if your method isn't the same as the mark scheme? Now, I don't know how the mark scheme works for math, but I think they'll get marks if they've done a valid mathematical method, won't they?
Yeah, we're really good at for the long questions. We've got a team of graduate students who mark the long questions, and they're looking out for other approaches and other things that you can do to get to the right answer.
Is it okay to?
Yeah,
Sorry, go on.
It is okay to abbreviate OMC on your personal statements. Probably help out other universities. Other universities you're applying to probably haven't heard of it. So maybe make it clear from context what it is.
Yeah, I was going to say, like, when you first introduce it in a paragraph, you might want to call it Oxford Online Maths Club or something, or like an online maths live stream, rather than just going in with OMC, because you've got to remember that you're applying to 5 unis, presumably, and they'll all be reading it and they won't all be James Monroe.
I gave it a short name that's got all the information that should work for other universities. It's Oxford, so they know that it was with Oxford University and they can find it if they want to find out what it is. It's online, so they know that you were joining in remotely and it wasn't like a in-person thing that we were doing online. Maths, they've seen you're doing a maths thing, and club for the kind of atmosphere of what that sort of thing was. If you watch some OMC stuff and explain maybe once what that stands for, or just from the context, they'll work out what you were watching. Just the word watching or thinking. Are international students less likely to get offers as opposed to UK students, assuming all other factors are constant? No, and again, we're assuming all other factors are constant, so hold everything constant, differentiate. No, we don't have a quota of international students, we don't have a quota of UK students, we don't mind. When we're making the offers, we look at who's good at maths. Good. Okay.
Someone's asking about comp sci.
Oh, I know a little bit about computer science.
I don't know whether they mean comp sci and maths or just comp sci. But will it look worse if they're doing biochemistry and maths? I don't know if we can answer that.
It's a question I get. Is that a question about further maths, maybe?
Oh, maybe the lack of further maths might put you at a disadvantage.
I see. And if that's the thing they've said in the comment underneath. I think the computer science department, big fans of further maths. If your school or college offers further maths, then I think they're big fans of doing further maths if you can, but not quite as big fans as me. I really
someone's
like
just
further
asked.
maths.
Doing further maths less important for comp sci and phil? And I think the answer is yes, compared to maths.
Yeah. In practice, most of the computer science students who did A-levels did further maths.
Yeah.
In practice, the people who get offers.
Yeah.
But these things are quite heavily correlated with each other, so it's quite tricky to talk about all other factors being constant. But yeah, in practice, like over 90% of the CS students who did A-levels did do further maths. Yeah, okay. Will, hi. Will is doing Tamua as well as Matt. Sorry about that. Should I try to get my Tamua score to Oxford? No, thank you. I don't need it. We've got the Matt, so we don't need it. Yes. Don't want it, don't need it. Sorry. Okay, good. That was an easy one. Tamura is another maths test. Let's be serious though. Tamura is another maths test. It's got multiple choice questions on it. If you want to try some other maths questions, then Tamura is there as a source of more tricky maths questions. But no, Oxford, we don't use Tamura. We also don't use STEP, before anybody asks that one as well. Someone has asked about further maths again. Yeah, okay, if you discovered a love of maths in year 12, doing a bit of AS further mathematics is what I would usually recommend that people do. If you can, if you've got the opportunity, I think you'll really like it. It's got complex numbers in. So all these questions that people have been asking about complex numbers, some of them are answered in AS further maths.
Exactly.
Not all of them. I saw one a while ago, sorry. I think it got flagged and then unflagged about when do you get your maths score back?
Oh, because someone answered and said that in January or something.
Yeah, it's in January. Yeah, okay.
Do you have to ask for it?
These days you get an automatic email.
Oh, you do?
You get an automatic email.
Back in my day, when I was young, we had to specifically request our admissions feedback, and that's how I got my maths score.
Yeah, and so many people were requesting their maths scores that we set up an automatic email to send out maths scores to Oxford applicants in January, just after final offers. Okay, what's this question? Very good personal statement. Less good in maths. Or is also disregard people's personal statements to get their maths scores below a certain threshold. Okay, so we don't have a hard cut-off threshold where we ignore people below that threshold. We'll look at your application, we'll read your personal statement, but you need to know that we've got lots of very good applicants. We've got lots of applicants who are really good at maths, and we're mostly using the MAT as the primary way to decide between people who are really good at maths. So if other people have got higher maths scores than you, then we're just more likely to shortlist them compared to you. Even if your personal statement explains that you're really excited about maths, you're really keen on maths, that's fantastic, but unfortunately it's really competitive. We have about 10 applicants per place for mathematics at the moment, which is quite a lot.
That is a lot.
Most of the applicants are really, they're like you. They're really good at maths. Okay. Cool. Do you want to answer one, Flora? Is there one you've seen?
Sure. I can't answer that one. How important is? This is too much of a big question right now. How important is a personal statement? Does a really good personal statement put you at a good advantage? Yes, but it might not be as important as the MAT and whether you're going to do well in your exams for maths.
I forgot to cut to you for that one.
Oh, it doesn't matter. They can hear me.
They
can hear me, can't they? Okay, here's a question that's directed at me, so I'll answer it. How did I feel before the MAT? Well, the answer is I felt very nervous because I really wanted to get into Oxford and I was scared I'd mess it up. Probably the same as the way lots of you are feeling. You're really worried about it since it's very costly to take it in the country. Oh, I'm sorry, you don't want to screw it up. Listen, if you're studying for 2 hours every day, I think you're going to be fine. Everyone's asking me today, how many hours did you study for the MAT? How much did you prepare? And honestly, I was doing, some MAT prep, a few days a week, not every day, until it got to, the actual run up to the MAT, because I had work to do for my other A-levels. I was juggling different things, and so, any maths that you're doing, if you're doing a maths course, A-level maths and further maths, you're doing maths problem-solving questions, you're watching this live stream, all of that is preparation, as well as, sitting down and attempting math questions by yourself. Strengthening basic concepts is good. My recommendations for preparation are, make it interesting. Watching this is more interesting than just sitting by yourself. Try and talk to maths friends if you have any. And yeah, trying any kind of like UKMT maths problems, anything that you find on the internet that's like challenging maths problems. You can look at step questions as well, because they're often like a different style and they're quite challenging. But yeah, mainly just believe in yourself. You know, at the end of the day, you're going to prepare and everything, but you're going to use your kind of natural problem solving skills in that exam, because it's not the kind of thing where you can revise and like know that you're going to get full marks. It's not that kind of exam. So you just have to do your best and believe in yourself, and it'll be okay. Do I ever regret picking Oxford for math? I mean, no. During my first term, there were some moments where I might have come close to saying maybe, because I found it very difficult. So I think what you have to understand is there will be a lot of hard work. It will be like an uphill battle to begin with if you're anything like me. And you'll find it difficult, and you'll think, oh my goodness, this work is so impossible, everyone's cleverer than me. How did I think I could survive here? But the answer is you just keep going, and then you do survive. And collaborating with other people helped me. Realising that it's okay not to finish a problem sheet helped me, because the style of work is different. So I think I had difficulty when I was thinking I was supposed to be finishing these sheets, and you're not supposed to be finishing them. You're just having a go at all the questions, and then you have tutorials where you understand everything, go through everything, and it's okay. But yeah, mostly I don't regret it at all, because it has been an amazing experience. If you look at the kind of course lists of some unis, you don't get to do topology until third year or fourth year. And I know I bang on about topology, but it's just a good example, because at the Oxford Maths course, you get to do it in second year. So now one of my textbooks, which I'm reading in preparation for this term, it says it's a graduate maths books series. And I am not a graduate, I'm just going into third year. But I'm getting to see a lot of maths and a lot of, you know, areas that I'm interested in. So I love the Oxford Maths course, and I love Oxford and like the friends that I've made there, the college community. I'm really going off on one now. I should stop.
Oh, bless. Thank you, Flora. Which college are you at?
Oh, Mansfield, which is a small college, which is near the centre of Oxford, but not on a main road. So it's like really well located. And there's 7 people in my year doing maths, and it's, you know, it's small, but it's nice. Like, there's quite a few people doing maths because the college is small, but it doesn't do every single subject. So like, there's no one at my college doing chemistry or biology. There's no one doing computer science, but there is people doing like maths, physics, engineering, and obviously other subjects too, like English, history, PPE, law.
A couple for me, I think.
Yeah.
Do I need to take some math competition like UKMT or Euclid, which I haven't heard of? And I'm typing an answer for this one. I'm not sure why. Just to say no, MAT is fine. That's the admissions test that we would like you to take. Someone called Hugh wants to know what we do, what prep they can do after past papers for math. I guess I'd recommend Tamua or STEP, or if you want to do the same style.
I just typed that.
Aha, there we go.
Like the exact same. Tamura or STEP papers are going to have similar questions on.
Looking at other maths, because maths got this very limited syllabus, so looking at other maths content. Yeah,
this is the thing, like if you're doing further maths A level, then you will have done more kind of baseline maths content in your schoolwork, but you may not have explored like problem solving questions where you take it beyond the syllabus. I mean, maybe you have, depending on what textbook you have. I think my textbook had these questions where it's like, here's an extension that's like, think about how you would prove this, or think about how you would extend this. And so that kind of thing is useful to just like consider all those extra little extension problems, and like the content that you're seeing, and like how it could be used in a different way.
Okay, the one question at the top that's very specific about not having a standard conditional offer, I'm going to type a proper reply to you after we're done being live. So I'm going to ask that one as well. Hey Flora, do you know?
Yeah.
Yeah. Do you know this student from Mansfield who's been on the Oxford Online Maths Club. In
Yeah,
episode
he's from Oxford Online Maths Club, and I do know him. Ittihad is my friend's college son.
You're going to have to explain college son now.
Oh, sorry. So college families are a thing where it's to help people kind of feel welcomed into their community and settle in and have like people to talk to in older years. So we have this tradition where people get college married, or you can be a college single parent if you want to nowadays. And you can college marry anyone. The marriage is not romantic, it's strictly platonic. So you college marry your friend, usually of a different subject, and then you get allocated college children who are students in the year below, so freshers who do a subject which is like the same as one of your subjects. So I married a historian, and so we have maths and history children who are just students in the year below who can talk to us about, you know, their course or anything that they're worried about when they're coming to uni. So my friend has some college children who do maths, and one of them is Ittihad, and he's nice, and I've met him.
And was on the Oxford Online Maths Club.
I don't know if I can even approve this.
Oh, I left it for you.
I mean, I'll approve it if you want. So, no, I'm not single. I don't know why you're asking, though.
Anyway, okay. So, there's a question about other unis as well. About further maths as well. I guess there's a general question here about other universities, which I can't really comment on. I guess the advice that I've typed below that might be helpful for other people to hear is it's a good idea to contact other universities directly to find out what their policy is, because everything we're saying here, well, most of what we're saying here is Oxford policy. Some of it's not Oxford policy. It is not Oxford policy for whether Flora is single or not. Right, okay. Do you want to recommend any books?
So
there was a question about book recommendations.
Ooh, I'm going to come up with my standard book recommendations in case you haven't heard them yet. Flatland and Flatterland are two amazing books. One of them is old. It was written as mathematical fiction, but also kind of low-key as a critique of Victorian society. And if you're thinking, how is that even a thing? Read it and find out. It was really interesting. And also there's Flatterland, which is a more modern, I say modern, it's still probably written before you were born, but like it's more modern than the Victorian era. And that's about lots of different areas of maths. And they go to about dimensions, different spaces, geometry, topology, projective planes, amazing stuff. Read those. Also, books by Ian Stewart are really nice for like introducing you to different bits of maths. Cool.
The question at the top now is, are there other universities that consider your maths score? The answer is
yes.
Warwick, Imperial, Durham and Bath have got different arrangements to look at your maths scores. There's more information on the MAT page. If you can find the page with MAT information, actually the one on screen is the MAT Livestream page, but if you find the MAT page, then there's more information there about how Imperial and Warwick and Bath and Durham use the MAT. You get an email if you're an Oxford applicant. You get an email in January with your maths score, which you could just show to people if you wanted to. But as far as I know, those are the only people using maths in a systematic way as part of their admissions process. Hugh would like to know what the Oxford Online Maths Club is. Do you want to say what it was?
Yeah, I do. I really do. So OOMC, obviously someone's already typed, it stands for Oxford Online Maths Club. It is on hiatus, that's true. So Oxford Online Maths Club was a live stream pretty similar to this one, except instead of just doing math content and math questions, we did a variety of different maths things. It was just like a selection of like, here's a taste of university maths, here's some Olympiad questions, here's a random problem solving thing that you'll never actually do at school, but it's fun math and it's interesting. And so James ran it like earlier this year, and there were lots of different student guests. One of the recurring guests was, of course, myself. I did an episode about topology, which is it's a type of maths, which is like weird geometry where you consider like the form of things rather than actual like distances and lengths and angles. And I also did a session about the Penrose tiling, which is this fun shape pattern thing that you see at the start and at the end of the live streams and on the Oxford Maths website. I explained about kind of aperiodic tilings, which are a special type of pattern. Watch the video to find out more. Basically, they were all on the Oxford Maths Plus channel, which is the same YouTube channel which this is on. So I think if you scroll back, you should be able to find them. Oh, do I have any college children who are older than me? So I had so my college, Mansfield, does this scheme called like the Visiting Student Programme, where students from other countries come to Mansfield and study there for 1 year. So it's like a kind of, year abroad exchange program. So lots of students from America come and study at Mansfield for 1 year. So one of my college children is studying in America, and I think she's like the same age as me. I don't know if she's actually like a month or two older or younger, but I think she would be like around the same age. So yeah, college children is a very kind of vague term. Like, they're not your actual children. Usually they're only a year younger than you. If they did a gap year, then they'll be the same age as you anyway. So the age thing doesn't matter. The experience of what it's like to study at Oxford matters. So it's the fact that you have more experience than them, so you kind of show them the ropes a bit.
I wasn't quite ready. I'm still typing a technical answer to that one.
Oh, it's okay. It's fine. I can talk about something else. Someone said, Flora, did you know me? I don't really know what they mean.
It's because they've got a minor celebrity as their username.
Yeah.
They're trying to find out if you know about Formula 1.
I'm sorry, I don't. My friend does. Christian is a big Formula 1 fan. I am not.
Oh, Christian from the Oxford Online Maths Club, maybe.
Yeah, from the Pigeons episode of Oxford Online Maths Club on the same YouTube channel.
Brilliant.
Just a bit of sneaky advertising. I mean, it's true.
It was more sneaky half an hour ago when we mentioned it the first time.
Every Oxford applicant writes about Pembrose tiling. I hope that's not true. I reckon I wrote about it. It's a bit cliched, maybe.
I tried looking at some stats on this. It's quite hard to get everyone's personal statements together to start doing the statistics on how many times Penrose tile has been mentioned. But I made one giant PDF with everyone's personal statements on, so I could go like Control F Vicky Neal or
that's amazing.
Control F Unique to see who was mentioning Unique in their personal statements.
Looking back, I mentioned Vicky Neal's book, and I bet so many other people did. It makes me think, oh yeah, you thought you were special, like mentioning an Oxford tutor in your personal statement where you're trying to get into Oxford. But now it's like, yeah, of course everyone did that. But thankfully, they still accepted me, because I must have written some other good stuff as well about myself and why I like maths.
I've got a follow-up question on the MAT by other universities. Yeah. So, if you're applying to Imperial or Warwick for particular courses, then when you register for the MAT, or when your school or college or test centre registers you for the MAT, they can tick boxes to say which courses you're applying for, if you're applying for particular courses at Imperial and Warwick. And then if you do that, your school will be automatically and securely sent to Imperial and Warwick. You don't need to do anything, you don't need to tell us to do anything, you don't need to tell them to do anything, it just gets sent over. If you forget to tick the box, or if the box doesn't get ticked, or if you decide afterwards, oh yeah, I applied to Imperial, they should get my MAT score, then you've kind of missed the automatic step, but you can still get them to have access to your MAT score by sending them your M number, which is the MAT registration number. It's the thing you write on the front of the test. You get given a candidate number when you register. That candidate number is like your ID. So if you send it to Imperial or Warwick, or in fact also Durham or Bath universities, those 4 universities in the UK, if you send them your M number, then they can look up your MAT score. They've got a kind of encrypted copy of all of the MAT scores. They can unlock your MAT score if you tell them that you took the MAT and what your number is. You don't have to tell them that you took the MAT. You don't have to tell them your M number, and they can't see your score unless you tell them what your ID number was. But most people, if they're applying for Imperial or Warwick, they just tick the boxes when they get registered to say, I'm applying for Imperial and Warwick, and then the score just gets sent over automatically. Good, mm-hmm. Right, okay. I can talk about that for absolutely hours, because some of the encryption and automation was stuff that I did a couple of years ago. So, good times. You really don't want the day in my life video. It's a lot of coordinating
Oh,
with
but they do.
universities. If any of the other universities are watching this, I love working with you. This is brilliant. I love that we're sharing all this data. It's great. Wow.
So someone's asking, when is the deadline for MAT registration?
The deadline for MAT registration is the 15th of October in the year that you take the MAT. It's the same as the UCAS deadline.
Which is my birthday.
It's also Flora's birthday every year on the UCAS deadline. Every year, it's the UCAS deadline, the MAT registration deadline, and Flora's birthday, all every year on the 15th of October.
Yeah. Some of the friends I've gone.
No, that's it. You're recommended to get registered slightly before that, please.
Yeah. Don't leave it till the last minute. I was just going to say some of the friends I made in the first term of uni, obviously we're fresh out of kind of like the uni application cycle and UCAS and everything. And when I told them my birthday, they remembered my birthday based on the UCAS deadline. But my friends in sixth form had remembered the UCAS deadline based on my birthday. And it's just basically, it's a really useful thing to have your birthday on the UCAS deadline. I found it quite funny, you know. Obviously, you know, me and all of my very organised friends sent off our applications long before the actual 15th of October, so we were just, you know, celebrating my birthday on that day rather than worrying about uni applications. But but it's just funny. Ooh, someone's asked me a question. Has that question just disappeared? Did I click the cross by accident?
Was it, do you have friends from other colleges?
Yeah.
And is it difficult to?
Yeah.
It's top for me.
Gone.
Slido's a bit weird for sometimes.
Oh, okay. Oh, it's appeared now. It just took a minute to appear. Don't worry. Flora, do you have friends from other colleges, and is it difficult to? So, yes, I have friends from other colleges, and is it difficult to? Or depends, like, if you try to, and also on the context. So, like, when I was in first year, we had these computing classes where you do a bit of like kind of basic coding on MATLAB. And by the way, for everyone listening, do not worry if you've never done any kind of coding or computing, because like they start with very basic things and you get told what to do and you have a whole instruction booklet and it's fine. It's not too difficult. But so we had these classes, and the class was in the maths department with like a PhD student, and the class had like some people from one college and some people from another college in. And so I chat to some people from another college, and you know, you'd say, oh hi, you know, and you find out that you know someone in common, and you like talk about maths and whatever you're doing, and it's just easy to make friends. And also when we had in-person lectures, so for my first 2 terms at Oxford before the pandemic hit, you'd end up sitting next to people, and people in the lecture theatre, when you do have in-person lectures, people they have like a spot where they want to sit on a certain row. Like some people want to sit right at the front and put their hand up all the time and like talk to the lecturer. Some people want to sit right at the back and like have a nap. I do not advise having a nap during a lecture, just for the official statement. And some people, like me, sit like with their friends kind of in the middle. And so I got chatting to some people from Queen's College and made friends with them. So then I'd often see them like around Oxford when we were walking to and from lectures and stuff. And one of my good friends who does maths, who also I met from just being in lectures, being in the group chat for our year group, and just like kind of messaging, because he's chatty. If you're a chatty person, I'm going to say it's very easy to make friends wherever you are. And I am a chatty person, as you can probably tell. So I have a friend from Teddy Hall as well, which is St Edmund's Hall. So yeah, and you know, maths people, they find each other regardless of college. But I will say that it is a lot easier to make friends at your own college as well when you start, especially depending on COVID restrictions and whether lectures are going to be online. Like at your college, probably there'll be like a dining hall where everyone goes and sits, or there'll be a common room, or there'll be people who live near to you on your corridor, and it'll be easy to make friends with them because they'll be in close proximity to you every day. So like a lot of my friends are people who do physics at Mansfield. What's my favourite library at Oxford? I don't want to crush everyone's dreams by saying I've not actually visited that many libraries in Oxford. For 2 reasons. One being that I'm not a humanities student, and one being that COVID. But basically, I've been to like the Bodleian Library, but I haven't been to all the like fancy Gladstone Link Underground bits. And the Radcam. Haven't been to like all these other libraries people talk about, like there's the Social Sciences Library. Have been to the Radcliffe Science Library, to look round, because you got a tour of that, because I do maths. If you do like a maths or science subject, you get a tour of that in Freshers Week. I mean, you may not get that depending on COVID, sorry. And to be honest, my favourite library in Oxford, I'm going to go with my college library, Mansfield Library, because it has a really cool ceiling and really ornate wooden bits, and it's not too big, so I know where to find the maths books. They're over at the left at the back, and there's lots of maths books. It's actually really good having a college library, because I'm going into third year now, and there's never been a maths book that I like particularly wanted that wasn't in the college library. So like they have a broad range of things. Do I have any friends from Worcester? No, I don't think so. Sorry.
Not a comment on Worcester College.
What?
No,
this is not a
comment about Worcester.
No, this is not a comment about Worcester College at all. I just don't happen to have friends from there. Like, I know some people from Hertford and from Wadham. I know a couple of people at Christchurch, but like that's just a chance thing. How do we get the exams gown thing when we get into Oxford? You mean like where do you get your gown from when you get into Oxford? So there's like places in Oxford where you can buy one. There's shops like called Shepherd and Woodward. There's a shop called like the University Shop. Basically, if you just like walk around the centre of Oxford, one of these shops will kind of like stand out to you, because they'll be like, we sell Subfusk Oxford gear, gowns, etc., etc. And in some of the information that you'll get sent by your college when you do get into Oxford, if you do get into Oxford, sorry, they'll tell you like what kind of the requirements are for academic dress. Basically, academic dress is what you have to wear when you matriculate, which is like the initiation ceremony. When I say initiation, I don't mean like where people do weird cult things. I mean where you go and like sit in a room and they speak Latin at you, and then you're officially part of the university.
Matriculation. The start of the course. Okay.
Yeah, the start of the course. So you wear it for your kind of beginning ceremony, and then you wear it for in-person exams. I think they might have lifted that requirement during COVID, but I didn't have in-person exams during COVID. I had online ones. It's all very complicated, but ignoring the pandemic, you wear it for exams and for graduation. And Subfusk consists of white shirt, black skirt or trousers, black socks, tights, whatever. And then you wear either a black ribbon, like a velvet ribbon, or a black bow tie, or a white bow tie, or a black long tie. And you can mix and match any of these options. Subfusk is not gendered. That was the PSA.
I think Subfusk is the weirdest thing that I learned about when I started at Oxford.
It is a weird thing.
Because it's an 800-year-old university, they have some traditions, or they have some fancy dress that is not as important as... Sometimes it feels very important, but it's not important.
So
right, okay. Should we do a couple more and then wrap up?
Yeah, I was just going to answer this about the Oxford shops gowns thing. So do we have to get gowns from Oxford shops? I guess you could get it from your hometown, but I don't know where you live. But my hometown doesn't have shops like that. Because I live far, far away from Oxford, as mentioned previously. So like. It's easier if you go into a shop in Oxford and just say, I'm a fresher starting at Oxford, they'll know exactly the right type of gown that you need. It's called like a commoner's gown or something, because there are different types of gown depending on whether you're just a lowly undergraduate starting out, or whether you are someone who's like got a first in your exams, or whether you're someone who's like a choir scholar, or whether you're a postgrad or like a professor. There are different types of gowns, so basically make sure you get the right one. And the best way to do that is to go in Oxford. You don't need it like before you start, so you can get it when you go to Oxford, like in Freshers Week, or even like at the end of Freshers Week, in first week. I mean, you're cutting it a bit fine then though, because matriculation ceremony is normally at the end of the kind of first week of term. Someone was asking about being dyslexic and finding it hard to pick up a book and read it through. I don't think you'll be looked down upon if you've not read many books. Since you're applying for maths, I think there are other ways that you can like consume mathematical content. Like presumably it will be made known on your application that you have dyslexia, and I think the application's not going to be considered in that context. And also there are loads of ways to consume mathematics. So like you're watching videos, you know, you're trying out maths problems, you're like consuming maths in other ways. You know, you can listen to podcasts. You basically, you don't have to read a book specifically. Websites are good too.
Or even just trying bits of maths yourself. With,
What's
reading
your
large...
gown called?
Yeah, I didn't understand that at all.
Well, I think they mean what kind of gown would you be able to wear given your status within Oxford University. And so I'm going to say, are you a member of academic staff? Because then you would just wear one of the ones that, like... Oh, no. He doesn't get a gown. He's not special.
I have a very complicated status with Oxford University.
Okay,
I put an
let's
answer
not
on
go
that
into
one.
it then.
I said, when I was at Cambridge, the gowns were just called gowns, and I had a gown called a gown. Good, right. That was a lot of gown chat, which could be the name of our podcast. We're not going to start a podcast called Gown Chat. Don't worry. There are a couple more that I've missed, but I've started them on the way through. They can't see the stars, but I can see the stars. So I'm going to go back and type answers, including a couple where I said live I would type a proper answer to them. Including like, Maths and CS still coming in here for Maths and CS questions as well. In particular, sorry, we're laughing because the question, where do you live?
Where do you live, Flora, just came up. That's why we're laughing. I already answered this. I'm not going to go into specifics about my address because you do not give your address out to strangers on the internet, everyone.
Stop trying to dox Flora. Right, okay.
Where I live is in England in the northwest. I think that's a broad enough region that people aren't going to track me down.
Okay. And someone's called for hashtag Gown Chat, which is the short-lived podcast that we just invented.
And on that note...
Thank you very much, Flora.
Thank you, everyone.
This was fun, having two people sharing the square in the top of the MAT live stream. I feel like we did quite a lot of integration, did quite a lot of problems. I've got to type some answers, but I'm going to say goodbye for the live stream here. Goodness knows if anyone's still here. Right, okay. See you next week for the next Oxford MAT live stream, where we're going to talk about a different topic. People are saying thank you, Flora, in chat as well. Cool, right.
Aww.
Good. See you next week. Bye.
Bye.